We're now going to move on to section 5-2, polynomials. Before we do move on with our new notes, we're going to go over a warm-up quickly to review what we learned in 5-1. I'm going to give you a few minutes to pause your video and work on your warm-up. When you finish the warm-up, you may restart the video and check your answers to make sure that you are correct. The answer to number 1, when we have a power to a power, we apply our rule. We take -2 to the 4th power, which is 16. Then we multiply our exponents, a to the 12th, b to the 20th. If we go over to number 2, again, we have a power of a power, but our exponent on the outside is negative. So in order to make our negative exponent positive, we flip our fraction. So then we can square 3/5 and we get 9/25. If we move on to number 3, we want to simplify what's on the outside of the parentheses, which is actually a fraction 16/2. So that reduces to 8 in the numerator. Then we can simplify our power to a powers. So here we have x to the 9th power, y to the 3rd power in the numerator. In the denominator, we have x to the 4th power. 0 times 4 then gets rid of our y's. We then have to simplify this to get 8x to the 5th y cubed. Then we go on to number 4. In number 4, again, we have a fraction to reduce. When we reduce -6/18, we get -1/3. We move on to our a's. No a's to reduce, so we have a to the 8th power. Then we go to our b's. We have b to the -3rd, which we want to bring down to the denominator to get b to the 5th in order to make those b's positive. And our c's we bring up to the numerator in order to make those positive as well. Moving on, evaluate using scientific notation. Again, we have our fraction to reduce. 40 divided by 5 gives us 8. And then 10 to the 6th and 10 to the -1 are a common base. So we bring that -1 power up to the numerator to get 8 times 10 to the +7th power. Next, we want to express in scientific notation for number 6, a and b. Remember, move your decimal point over so that you have one number to the left of the decimal point. So all the way over there, we get 5.3 times 10 to the -7, since we moved our decimal point to the right. Next one, again, we want to move our decimal point so that we have one number to the left. So all the way over to that point, so we get 2.64 times 10, this time to the +9th, since we went to the left. All right, moving on. We're going to go over some terms. First is polynomial, an expression containing one or more monomials, a number, a variable, or a product of a number and a variable would be considered a polynomial. Terms, monomials in a polynomial. For example, 3x squared y. Terms are arranged so powers are in descending order. Again, you may not always see x and y as your variables, so when you have variables other than that, put them in alphabetical order and then put them in descending order as well. Then we have binomial, the sum of two monomials or two terms. You can see an example there, 2a cubed b plus 5b squared. Trinomial, the sum of three monomials or three terms, 2x squared plus 5x plus 10 is our example. The degree of a monomial, the sum of the exponents of the variables. So a constant, since it has no variables, has a degree of 0. 0 itself has no degree. Degree of a polynomial, the degree of the term with the highest degree. So again, you're looking at all the monomials that make up your polynomial, add all of the exponents together in each of those terms, and then whatever term has the highest degree, that's going to be the degree of your polynomial. Find the degree of each. So if we look at this example, I do have a binomial. It's separated by addition, my two terms. So I look at each of my terms. My first term has a degree of 5, since p has a power of 5. Then my next term actually has a degree of 9. 2 plus 7 gives me a degree of 9. That's the highest degree. So my degree of that polynomial is 9. The next one is actually a monomial. So all we have to do is add up all of our exponents, and that gives us the degree of that term. Don't forget there's an exponent of 1 on your b. So 3 plus 1 plus 8 is a degree of 12. All right, moving on. We're going to subtract and simplify. Remember when we do this, subtraction, we want to change to adding the opposite of all the signs inside our second parentheses. So we change this to plus, and then change the sign of every term inside your second parentheses. Then we just combine like terms. So 2a cubed plus negative 1a cubed gives us 1a cubed. Then I go on to my a squareds. I have none, so I go on to my a's. 5a plus 3a gives me plus 8a. And then on to my constants. Negative 7 plus negative 2 gives me minus 9. Next example, multiplying binomials. Remember to use FOIL. First, outer, inner, last. First, outer, inner, last. So, if I look at these two binomials, I'm going to multiply them together by doing first, outer, inner, last. If you like to use the rainbow method, you may also do that. So I'm going to multiply x times x, which gives me x squared. Then I'm going to multiply x times 7. Then I'm going to multiply 3 times x. And lastly, I'm going to multiply 3 times 7. Once I've done that, I can combine my like terms. To simplify. Let's try the next one. Again, we're going to FOIL this out. Okay. So 2p times 4p is 8p squared plus 2p, then we go on the bottom, plus 12p plus 3, combine our like terms. And we've simplified our polynomial. Let's do one more example. This time we have a trinomial multiplied by a binomial. So you have to take every single term in your first parentheses and multiply it by every term in the second parentheses. So we're going to start with our a squared. A squared goes to a squared goes to 2. So a cubed plus 2a squared. Then I'm going to go to my next term. When I go to my next term, I have 3a times a, 3a times 2. And then I go to my last term and do it one more time. Negative 4 times a, negative 4 times 2. Then I have to combine all of my like terms. When I simplify this, I get a cubed plus 5a squared plus 2a minus 8. Again, these two were like terms, and those two were like terms.